Speaking of like size in the universe, you know like atoms, right? Is it possible for like you to destroy an atom and like recreate it somewhere else? Like wouldn't that be teleportation to like, you know?
Destroy an atom
Like
and recreate it in
like
another location in
to like
space.
basically to move an atom from one spot to the other, but like but not like linearly, but through teleportation to like move from one to the other like that. Yeah, it's hard to explain because teleportation doesn't exist yet. Like the Beam Me Up Scotty and the Star Trek.
I actually never watched Star Trek, so to be
But
fair, I don't.
no, but like that expression, and
Yes, I do. I've heard of it.
So it's basically, if my memory is correct, it's just like they convert their bodies into light, and then the light just gets transferred to wherever they want, and boom, teleport. So
I mean, so I know that, like, what you're saying is like 50% right and 50% wrong. The way that teleportation would work, have you ever heard of quantum entanglement?
no, Pete, enlighten me.
So basically, what it means is a particle, a subatomic particle, electrons usually, and whatnot, they would become entangled if and this can happen theoretically at any distance, large and very small. Um, they become entangled when they have the same orientation about themselves. So, in other words, an electron spin is one way to measure its orientation. And there are a lot of other things, but I'm just kind of breaking it down really simplistically for you right now. So, anyways, the way that this works is, let's say I have one electron in one point in space time, right? And it has a spin of certain, like we'll say it's spinning in the up direction, whatever. Then I have another electron in France, right? And that if that thing's entangled with the electron that's right here next to me, then that thing is literally spinning the exact same way as my electron, right?
Okay.
And so theoretically, using that idea, if you can kind of recreate that with all of the atoms and all of the particles in your body, that would mean that you'd be able to essentially teleport someone from point A to point B.
So if two electrons have the same spin, they can move between each other?
Yeah, well, it's not only spin. There's a lot of stuff. Like I said, I only took one aspect of it. Like I said, very simplistic definition. But the whole key here is quantum entanglement.
So basically, in some space anywhere, I have all the atoms in my body have to match all the atoms in another space in the exact same shape that I am, and then theoretically I can jump between the two.
Wait, say that again?
If my atoms of my body are matched with another group of atoms that are the exact same shape and exact same characteristics of spin and whatnot
Mm-hmm.
in another plane in space, then I can move between the two spaces within where I am and where I could be.
Essentially. But it sounds more like cloning than it does teleporting, but in reality it is teleporting. Because there's this also should not be confused with this thing called quantum tunneling, which technically is also applicable.
Teleportation.
Huh?
Is it also teleportation?
Well, it's weird because the answer is yes and no to that as well.
This is judging from the name quantum tunneling, it sounds more like you're just moving your atoms very quickly from one place to the other. You're not really transporting them like instantly. Is that right?
Yes. I mean, well, yes and no. Dude, can I just precede this by giving a quote from Richard Feynman and saying, if you think you understand quantum mechanics, then you don't understand quantum mechanics. And this guy was one of the smartest human beings to ever live on this planet. He was a professor at MIT. He worked on the atomic bombs and he was literally I don't know if he was a Nobel laureate, but this guy was smart.
He was a genius.
He was smart, and even he struggled with this stuff. So don't take this from me like I'm some kind of guru on quantum science. But anyways, so what it is
I
also
should just quit everything I'm doing and just study this because it's so fascinating.
It is pretty
It's
fascinating.
basically
especially 'cause
mastering
it's so
mastering
out of
space.
our intellectual reach sometimes.
Yeah, but it's basically like mastering time and space.
I
Sounds
mean,
cool. Until you actually read the books, in which case it's boring and hard.
no, it is difficult. So, anyways, a quick description of quantum tunneling is, let's say there is, do you know what electric potential is?
Yes? No.
Think of voltage. You know what voltage
Okay, a
is.
current, yeah. An
No,
electric.
no. Current and voltage are very different.
Voltage is the valuing of electricity, no?
No. Voltage is the difference in potential between two points.
Oh, okay.
Okay, so anyways, let's imagine a potential barrier. So, right, like I have a point A, point B. There's a voltage between point A and point B, or potential difference, which equals voltage, right? Point A,
Right.
point B. So let's imagine those 2 points make a barrier. It's called a potential barrier, right?
Right.
What quantum tunneling does is it basically allows a wave function or a particle, because light can be both a wave and particle. Once again, quantum mechanics is weird, man. It allows this thing to propagate through that potential barrier, and essentially it's not moving through it, but rather it starts at one point and then just ends up at the next point type stuff.
And
If that makes any sense at all. So it like imagine there's like a super shifty just imaginary tunnel there, and it allowed it to tunnel between the one side to the other side in an instant, and
what's the barrier supposed to be?
it's just a potential barrier.
What if there is no barrier? Then quantum is this just basically quantum entanglement, but with a
No.
barrier in between?
No. This is totally different.
What if there's no barrier? Then you don't need a tunnel. You just walk from point A to point B.
Well, sometimes you can't because there are other things prohibiting. Like, for instance, light bounces off walls, right? It can't just travel through a wall.
Maybe if it has a power drill, it could.
Okay. I mean, if you want to just think of it super simplistically, then yeah, totally. But no. So the barrier is there to no. It basically means that this phenomenon occurs basically for particles, waveforms that move from one place to another with something blocking their movement, and they're able to move through that barrier even though they're not
Right.
supposed to. So they literally just appeared from point A to point B.
Is this real or this is
This is real.
completely?
This
So like
isn't-
you could
this is a
theoretically
thing.
do it.
What?
So you could theoretically do this. This is a thing that we could.
No.
Right?
This isn't theoretical. This is real.
So why aren't we doing it?
Well, because I'm not a beam of light, man. I can't do it.
So only light can do this attribute, go through quantum tunneling.
Wave functions, yeah.
So I can't unless I convert myself to light.
Yeah.